This tutorial is on the insert curve function in Solidworks. If you're trying to model a component with curve geometry, reaching for the spline tool will probably be your first instinct. Unfortunately, while you can achieve pretty good results with this method, it's not 100% accurate and will fail at faithfully reproducing complex curves like aerofoil sections, parabolic curves and involutes. There are a couple of ways of modelling these curves in Solidworks. You can use the equation-driven curve function, that I'll do another video on, or you can use the insert curve function, which imports a file with a set of coordinates for the curve you're trying to create. In this example, I'll be importing a set of coordinates for creating an aircraft wing. The first thing we need is a set of coordinates in the comma-separated value format. If you Google for aerofoil profiles, you get a lot of results, but I like using World of Krauss. I'm cheating a little bit here because I already know this section I want to use, but you can search for a section using the attributes you want, things like lift-drag ratio, camber, or stall angle. On the right hand side is a download for the DAC coordinate file, which I'll save to desktop. I'll open it in Excel, choosing the delimited function from the first menu and selecting the space delimiter to split the file into two columns. So here I have my two columns, but the insert curve function works in three dimensions, x, y and z. The curve I'm importing is only two-dimensional, so I need to add a third column of zeros for the z coordinates. Once that is done, I need to check if there are any repeated points, as Solidworks will regard the file as corrupt because it can't draw a smooth curve between 2 points that occupy the same position. Now that's done, a quick note on unit systems. I'm using the millimeter kilo second unit system, so at the minute if I import this, I'll end up with a wing that has a chord length of 1 millimeter, because the coordinates are done setting the chord length as 1. The chord length, by the way, is the distance between the leading and trailing edge. It's a simple matter to scale the coordinates, so I have a chord of about 15 centimeters or 6 inches, which I do by multiplying all three columns by 150. I now copy and paste these coordinates to a new workbook, which I then save. A word of warning here, you need to use the save using the CSV file format, but have the file name include .txt at the end or it will not import. I'll save this to desktop and exit the workbook. In Solidworks, open a new part. From the menu select Insert Curve, curve through XYZ points. Now you need to navigate to where you saved the file and select it. After you check the preview, click OK and then open a new sketch on a plane parallel to the curve. Click on the curve and select Convert Entities from the sketch toolbar and click OK. That is your imported curve. From here you can either extrude, loft or sweep it to your heart's content. Thank you for watching.